All right, guys, so we're going to finish up the piecewise limits here, okay? And yesterday we talked about the piecewise just plugging in values, and we stopped with, we were talking about g of 2, right? And the problem is that, we can't plug into this first function because x has to be less than negative 2. We can't plug 2 into here because it has to be between negative 2 inclusive and 2, which is exclusive. Okay, so 2 is not included there. And then this last function, x is greater than 2. And so we can't plug in 2 there. So that's why g of 2 is undefined. Okay, there's nowhere to plug it in. Okay, there's no space for it. All right, so when it comes to limits now, you're going to approach it the same way. Okay, we're just going to plug in the values, whatever x approaches, to the appropriate part of the function. So the limit as x approaches negative 3, since negative 3 is less than negative 2, we're going to plug it into the first function. So you have negative 3, which is 3. So the limit as x approaches negative 3 is 3. The limit as x approaches negative 1, we're going to plug into this function, since x is between negative 2 and 2. So, what do we get? We get 1/2 times 1 minus 1 is negative 1/2. Lastly, we have x approaches 4. We're going to plug that into the first function. We get negative 4 plus 3 equals negative 1. And we plugged it in there because x has to be greater than 2, and 4 is definitely greater than 2, so we plug it into the last function. Okay? And those are all listed right there for you. Now, just a comment. I wrote, we do not care what happens at a point regarding the limit. Okay, that's not totally true, because in the last couple slides, we were looking at negative 3, at negative 4, and at 4. So we do care. I guess I should say, we sometimes aren't too worried about what happens at a particular point. We definitely care. So maybe I was a bit frustrated when I made that. I'm not sure. So we want to look at the limit now when the intervals change, okay? So, for example, we're looking at the limit as g of x approaches negative 2. But there's a negative 2 here, and there's a negative 2 here. So what do we do, right? That's the question. So whenever we're finding the limit of a boundary, right, where the functions switch, okay, for example, negative x and 1/2 x squared minus 1, depending on if the number's less than negative 2 or if the number's bigger than negative 2, okay, then our functions will be different, right? If it's less than negative 2, we choose negative x, and if it's greater than negative 2, we choose 1/2 x squared minus 1. Okay. So when that happens, we're going to find the limit from the left and the right. So we want to find the limit from the left. The limit from the left is negative x, right? Because if x is less than negative 2, right, that's coming from the left, smaller numbers, then the function's negative x. And then we plug in negative 2, which is 2. So the limit from the left is 2. From the right, numbers bigger than negative 2, or, slightly bigger, we choose the second function, 1/2 x squared minus 1. Okay? Then we get 1/2 times negative 2 squared minus 1. Then we get 2 minus 1 equals 1. So we would say, and there's again the work there, so you can see, since the limit from the left is not the same as the limit from the right, the limit as x approaches negative 2 of g of x does not exist. Okay? So, at a boundary point, you want to look at the limit from the left and the limit from the right. So let's look at this again, right? So again, we're trying to find the limit of f of x as x approaches 2, okay? And notice at 2, depending on whether we're looking from the left or the right, the function changes, okay? So, the limit, and I didn't give myself enough space here. The limit as x approaches 2 from the left of 3fx plus 7 equals 3 halves times 2 plus 7, which equals 10. The limit as x approaches 2 from the right is 3x plus 4. So that's 3 times 2 plus 4, which equals 10. So we would say the limit as x approaches 2 of f of x is 10. Since the limit from the left and from the right are the same. Okay? All right, give myself a little more space here. So again, the limit as x approaches negative 5 of f of x. So again, the function changes at negative 5, okay? So again, that means we're going to have the limit as x approaches negative 5 from the left, 3/5 times negative 5 plus 2 equals negative 1. The limit as x approaches negative 5 of 2 times negative 5 plus 8/3 equals negative 10 plus 8/3, which is negative 22/3. So, the limit as x approaches negative 5 of f of x does not exist, since the limit from the left and the right are not the same. Okay? Now, there's some other nice problems down here you can do. You try to make the limit exist, right? So you're trying to find the limit of as x approaches 3, and you're trying to find the value of m here, right? So again, you do the limit from the left, okay? Because the function changes at 3, and we're evaluating the limit at 3. So that's 2 times 3 plus 7 from the left, which is 13. So the limit from the right has to be 13 as well. So you have m times 3 minus 4 equals 3m minus 4, right? You plug in x, and now you need to figure out m. Well, we're trying to make the limit exist, right? So that means that they have to be the same. So 13 equals 3m minus 4. You do a little math here. For the sake of time, I'm just going to give you the answer. So that would be 17 over 3. Okay? So, and then you can do it again down here. Okay? So the main idea here is when you're trying to find the limit of a piecewise function at a particular number where the function changes, right? So, and if, for example, here it changes from 3/5 x plus 2 at -5 to 2x plus 8/3 when x is bigger than or equal to -5, right? So it changes. So whenever that happens, when their functions are different, right, from the left and to the right, then the limits you're going to have to evaluate from the left and the right. If the limits are the same, then you just write the number. That's the limit. If the limits are different, okay, from the left and right, then the limit doesn't exist, okay? All right, fellas, have a great day. Your homework's on Delta Math, so check that out. There's only about 10 questions there, so I think you can handle that. And